Today we are going to learn about the construction for square root spiral, and this is another way of plotting the square root of a natural number on the number line. Now, for instance, we need to find the square root of 5. So, for square root spiral, we will be needing to draw 5 minus 1, that is 4 triangles in total. So for 4 triangles, and those triangles have to be right triangles. So in right triangles, you know that we need to draw perpendiculars. We also need to draw the hypotenuse. So what rule do we use in case of hypotenuse? So if we have square root of 5, what theory do we use here? So square root of 5 can be written as square root of root over 4 square plus 1 square. The root over 4 square is equal to 4, right? And 1 square is equal to 5. So 4 plus 1 is equal to root 5. So for drawing the square root spiral, we will be needing to draw the square root of 4. Now to draw the square root of 4, in the same technique, square root of 3 square plus 1 square. Now square root of 3 square is again 3 and 1 square is 1. So therefore we have square root of 3 square equal to 3 plus 1 equal to square root of 4. So you can see that we will need to draw again square root of 3. So for square root of 3, we can write in the same technique square root of 2 square plus 1 square. Square root of 2 square is equal to 2 and this is 1, so 2 plus 1 is 3. Same technique, you can see the pattern here clearly. And square root of 2 is equal to 1 square plus 1 square. So that's the theory part. And where do we get something like this? Something like this is easily achieved for right angled triangle when we use the Pythagoras theorem, right? And the left hand side becomes the hypotenuse, and inside the square root these values are the base and the perpendiculars. So we are going to draw the square root of 5. For that I will also give a tip to you, so that in number lines you don't need to use the marking in scale. When we mark the scale after drawing the number line, for instance I am showing you, now this is the number line, this is the line that I have drawn. Now if I go and point here and start marking every point, then the error increases. That is, the mark sometimes maybe into 1 and sometimes maybe a bit shifting somewhere else. If the marks shift, the diagram here won't give you the accurate result. So in that case, or in any case where you draw the number line, you don't need to mark every point. You can just take the compass, take any length of the compass as the unit, don't change it. I'm taking this much, okay, as the length. You can say whatever it is, and for every marking the unit shall be 1. So here it is 1 unit. Now from this 1 unit point you mark it again. This is 2 unit. So from 2 unit point you mark it again. This is 3 unit. Here the error decreases, okay. So this is 4 unit and we don't need more in our case, okay. So let us mark it to 0, 1, 2, 3, 4. So the number line is drawn. Once the number line is drawn, we have to draw the right angle triangle where root 2 will be the hypotenuse, and the base and the perpendicular will be 1 and 1. We already have the base here, and we need to draw another 1 unit perpendicular here, so that when we join those 3 points it forms a triangle, right triangle. Okay, so on 1 we need to draw a perpendicular. So for drawing a perpendicular, you can use the compass, draw the semicircle, and then extend it and draw the perpendiculars, but here we are not going to use it. So for drawing the perpendicular, we are going to take the set square, just place it over the line so that you can see the line from your side, and you can also see the point 1 here. You just draw this line. This is your perpendicular, and so this length that we have not changed. Okay, earlier we have taken it for 1 unit here, so the length in the perpendicular for 1 unit, I mean the scale, should be same. So we just mark. Okay, now you can just join these 2 points. And this value is nothing but root 2, and this is nothing but 1, because we have taken this scale as 1, so this scale will be also 1 unit. So we got square root of 2, and this is a right angle triangle. Now we need to repeat the process for the next one. On the next one we have root 3. So the base is here root 2, and the perpendicular here is 1. So here, which one we shall take the base? We shall take this root 2 as a base, and at this point we are going to draw the perpendicular. So just place it so on a way so that you can just observe this line below and the point here itself. Draw the perpendicular, which should be a bit more than the scale that you have taken. Back to the scale, draw the perpendicular. So this is root 2 and this is 1. So this is a right angle triangle. When we join these 2 points, and this right angle triangle has a base root 2 and a perpendicular 1. So the hypotenuse shall be root 3. So this is our root 3. Now for the next one, just repeat the process. We put it in a way so that we can observe the line here and the point also, and we draw a little bit more, than the perpendicular. So on repeating the process, I have not changed it. It is still the same, 1 unit. This is also 1 unit. This is also 1 unit. All the perpendiculars here are 1 unit, right? So now we join it. So when we join this third hypotenuse, so we have got 1, 2, 3 triangles. So this is root 4. You can see here how we got root 4. So we need to draw another one to get root 5. Place it. Draw the perpendicular. The scale is same. And that's the length of root 5 when our 1 unit is this. So this is root 5. If they ask you to draw root 5 centimeter, then you have to take this as 1 centimeter. Okay, once we have this length root 5, now we need to plot this root 5 on the number line. So to plot this root 5 on the number line, we need to measure this root 5. How do we measure this root 5? With this compass itself. Now we are changing the length so that it fits with root 5 here. So you can see here it fits here, so you can just draw it an arc from root 5 to cut this number line. So you can see that this point here is at same distance from O as it is this point. So since this is root 5, this is also root 5. So here you can just mark square. I'm just using the pen. You don't use the pen in your exam to mark root 5. Okay, so this point here is root 5. This is point 0. This is 1 unit. This is 2 unit, and this is 3 unit. You could see that root 5 is between 2 and 3. You can also verify it. 2 square, what is 2 square? 2 square is equal to 4, and 3 square is equal to 9. So the square root of 4 is 2, and the square root of 9 is 3. And you can see that all the numbers between 4 and 9, that is 5, 6, 7 and 8, and more than like 8.5 also, all their square roots shall lie between 2 and 3. So that is how we draw the square root spiral. If you still have any doubts, you can ask me without any hesitation. I will try to find some way to clear it out.